now that we've learned something about properties of alkynes and bonding in alkynes and how you make alkynes, we're ready to start talking about reactions of alkynes. In other words, what can you take an alkyne and turn it into? But before we do that, we need to think about the fact that because alkynes have a triple bond, you can add across it not once, but twice. So the question is going to be, if you react it with a compound that adds across the triple bond, does it stop after adding one, or does it go on and do it twice? Before you view the rest of the video, I suggest you stop and study and read page 263. It gives you a little background on reactions of alkynes. As I said, because they have triple bonds, alkynes can add one or two molecules. So what I've done here is I've drawn a generic alkyne. These two lines represent a hydrogen on each side, or carbon groups, or a hydrogen and a carbon group. Lots of possible molecules that have a triple bond. And then this AB is a generic symbol to mean something that we're going to be adding across the double bond. It might be two hydrogens, in which case it would be just H2, or it might be water that we're adding across the triple bond, or it might be an H and a bromine, or it might be two bromines. In any case, we could add it across the triple bond using one of those pi bonds to form the new bonds and get down to a double bond. Now I've drawn these cis. It's possible it could be trans, or it's possible it could be both, depending upon the specific reaction. The point, though, is that the triple bond becomes a double bond, and we've added two things to the triple bond. But now we have a double bond, and what we've learned is that double bonds can add groups across them and become single bonds. So here's a second equivalent of the exact same reagent, and this is important in the discussion that whatever reagent you're adding first, is it possible that that same reagent would add again across the double bond and get it down to a single bond? That's what we're dealing with in this situation. So it turns out there are three possible scenarios. In some cases, a second one won't add to the double bond. It just, for whatever reason, it stops at the alkene. We'll see one of the reactions that does that. The second scenario is that it does add, but it's slower than the first one. For some reason, whatever reason, the triple bond is more reactive to this particular reagent and forms this compound faster, because this compound is now less reactive than the alkyne was, and therefore, even though it does add another equivalent of AB, it is slower. So this is the most useful of the three scenarios, because what you can do is you can stop it after you've added one, if that particular molecule is the one that you want, and you can stop at that point by just adding one equivalent of whatever the reagent is. Then it runs out of the reagent, and a second one can't add. Or if you want to, you could add two equivalents, and it would go all the way to the end. Although in some cases, you may have to crank up the condition some. In some cases, not. In some cases, just add two equivalents, and it goes all the way to the single bond molecule. We'll see a couple of cases like that. And then the third scenario is that the second reaction happens faster than the first one does. We're going to see one reaction of that type, where once you've added an equivalent across the triple bond, then this molecule becomes more reactive than this one does. And as soon as some of these start to form, they react with whatever reagent happens to be there, and they go all the way to the end. So this is the less useful of the three different scenarios, because, as it says here, you can't stop it after the first reaction, even if you only add one equivalent of the reagent. Turns out, as I mentioned earlier, many other reactions have the same series of scenarios. For example, turns out, we'll learn this in the next chapter, that an alkane can react with bromine or chlorine and replace a hydrogen with a bromine. Well, once you've replaced a hydrogen with bromine, you still have hydrogens. Can you replace a second hydrogen with a second bromine? And the answer is yes, and that can even go on further. This is one of those cases where we'll have to worry about, does the second one happen faster or slower than the first one? Can you stop it after adding just one? Can you stop it after adding just two? We'll see when we get to that chapter. Here's one that you're already familiar with, and we didn't talk about it in this sense earlier in this chapter, but you already know that if you take a dihalide of this type, by the way, it's called a Bic dihalide. Bic being short for vicinal, meaning in vicinity of. So if you have two hydrogens or two bromines next to each other, they're called vicinal, so this is a Bic dihalide. As you know from our earlier discussions in this chapter, if you take a Bic dihalide and react it with sodium amide, it takes off a hydrogen and a bromine and turns a single bond into a double bond. But you also know that if you take a second equivalent of sodium amide, it takes off another hydrogen and another bromine and turns it into a triple bond. So again, same reagent happening twice on the same starting material. So the question is, can you stop after the first one? And the answer is, although we didn't talk about it earlier, yes you can if you really want to, but it turns out most of the time you don't really want to. So you just go from the single bond with two bromines all the way to an alkyne. That's the end of this lecture. Thank you for your attention.